Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today I am going to talk about the last criterion of congruency in triangles, that is RHS criterion. There are two triangles ABC and DEF. In that, angle B is at 90 degree, angle E is at 90 degree. The hypotenuse of ABC, that is AC, and hypotenuse of DEF, that is DF, are equal, and any one side, in this one I have shown AB equal to DE, it can be BC equal to EF, any one side of each triangle being equal, then we have the RHS criterion of congruency met, and then we can say that triangle ABC is congruent to triangle DEF. Okay. If you come across a situation where there is a right angle present between two triangles and you happen to get the hypotenuse of those two triangles also equal, then immediately you should think about the RHS criterion for proving congruency. Let's see how the RHS criterion can be used in practice. Here is a problem statement where there is one angle PQR and there is a point in this region, that is point A. A perpendicular has been drawn on PQ from A, that is AM. Likewise, another perpendicular has been drawn from A to QR, and that is AN. So AM is perpendicular to PQ, AN is perpendicular to QR, and it is given that AM is equal to AN. So both these perpendiculars are equal. Now what we have to prove is that angle AQP is equal to angle AQR. In other words, AQ is the bisector of angle PQR. Okay. So let's try proving that. Let's look at the triangles, triangle AQM and triangle AQN. So in these two triangles, we know that angle AMQ is equal to angle ANQ, and that is equal to 90 degree. Okay, these two angles are at 90 degree. So the right angle part of RHS criterion is obvious. Now we also see that AQ is equal to AQ because this AQ is common to both the triangles. And from that, the hypotenuse part is also established because AQ is hypotenuse of AMQ as well as of ANQ. Okay. And also it is given that AM is equal to AN. This is given. So the S, that is one side, this AM is one side of AMQ, AN is another side of ANQ, and both are equal. So from that, RHS criterion is established. Therefore, triangle AQM is congruent to triangle AQN. Okay. Now using the CPCTC criteria, now angle AQM will be equal to angle AQN because these two sides are equal, so corresponding angles will be equal, and therefore we can also see that angle AQP will be equal to angle AQR. This is what we had to prove. right? So with this example, you might have understood how the RHS criterion need to be used. If you happen to find the two triangles which have one right angle each, then the RHS criterion should come to your mind, and then you should try establishing hypotenuse of the two triangles being equal and any one side in the two triangles being equal. And if you are able to establish that, then RHS criterion is fulfilled and the two triangles will be congruent. With these discussions on the congruency of triangles, you have understood by now how all these 5 criterions will be used, okay, to prove congruency. Thank you very much.